Hi everyone, my name is Thomas Kim. Today is May 24th, 2019. This is my 18th episode about the future of C++ programming language, C++2A standard. In this episode, we will learn about how to use stdref and std reference wrapper class. And we will also learn how to implement them. To follow this episode, please start your web browser, then visit extension talkplayfun.com. From this website, click this button to download C++ library extension. And you also have to watch this video, setting system environment variables for Microsoft Visual C++, GNU G++, and Clang. By clicking this link, you can learn how to make system environment variable settings for Visual C++ and GNU G++ and Clang++. If you haven't watched this video and haven't made proper system environment variable settings, then it might be hard for you to follow this episode. Click this button, Show in Folder. If you unzip this file, then you can find CPP extension folder. Copy this folder to your working folder. Then you can start Visual Studio and open the folder path. If you open it, you can find tutorials folder. Click this tutorials folder, then click this button O18 std ref cpp. Control V, Control V, Control plus, include talkplayfun output HPP. We will first learn how to use stdref. I will create a template function, template, type name, type. I create a function, it does not return anything, void increment, type n plus plus n. We increment n. I created a function, then void examples for stdref. Okay, I will create some string, talkplayfun, ss stream, auto, and talkplayfun, and I will declare an int n and initialize to 5, then stream before calling increment n. Okay, then we display n, and then we call increment n stream after calling increment n. Now we display n, and we call this function int main. I will copy this function name, paste it here, then start your command prompt. Please note that you should be in tutorial folder. In this tutorial subfolder, we will be using GNU compiler, G++, std, C++ 17, O18, std, ref, cpp. Hit enter. If we run A, So the value of n hasn't changed. Okay, n hasn't changed. Now we will try another one. I will copy this part, paste, Ctrl V. Before calling increment, I will modify it like this: int reference, then int reference, then here int reference. Now let's try it. We build our application using CMU compiler again. Now you can see the value of n is modified successfully. Okay, there is another way. I will copy once again. I copied, pasted it here. Now I say I will remove this part. Instead we will be using std ref, and here I will remove this part, std ref, and I modified like this. Then here std ref. Okay, now let's build once again. Okay, we combined. This works successfully. So when we declared a template function like this, template parameter argument like this, then if we want to modify the value of n, we have two choices. Either we specify template parameter type like this, or we can pass stdref. We can use two ways to modify the value of n. And now let's think about this. std thread. Okay, thread t. Now here we want to call this function, copy and paste it here. We have to provide type, parameter type, in this case int and n. Okay, we created a thread t runs immediately. Okay, now we wait, we join t join, wait until thread t returns. Now we copy this function once again. We copied here again. After the thread finished, okay, then we display here. Now let's run it. So after the thread finished, the value of n hasn't changed from here. It hasn't changed. Then how can you send it to here as reference? So let's try once again. Copy, paste. I will change it to s like this, s. Then instead of doing this, std ref. Okay, now we say s join. After thread s finished, I will change it after thread t finished. Okay, now I modified it. Then we build again. cls a. Wow, n hasn't changed. N hasn't changed because we have to pass n like this. I will change it to like this, reference, and I fixed the reference. Now let's build once again. CLS. First, it does not work. Okay, it does not work. So I will restore it. But in this case, it works. Now let's build once again. Okay, it's modified. In this part, we modified the value of n by calling this function using another thread. So this syntax is important. That's why I introduced this syntax. Okay, so if we want to pass n as reference, we have to call this is template function. We have to specify the type of t as reference, and we have to use this syntax. Okay, if we don't use this syntax, let's try this. Okay, let's try this. It does not work. Okay, so we have to modify like this. But most of C++ standard library functions are built using forwarding reference. So here I will create another function, template, type name, type, void decrement. Type, this is forwarding reference, -n. This is decrement. So to use that function, I will copy this part once again and paste thread, I say u. In this case, we are now using decrement, and we have to provide, this part is called template parameter argument. This part is template parameter argument, and this is function call argument. Okay, I hope you do not get confused, and I will make like this. It's easier to read. Now I will modify it to u, then u. Now let's try once again. CLS A. Now as you can see, the value of n is decremented properly. Now let's think about another one. What about if we are using lambda? Okay, std thread stub. We are now providing lambda function like this, and std. We also have to send ref n. Okay. Now in this case, we declare auto arg, and we scale return arg times arg. We scaled. I copy and paste once again. B. Okay. Please note that this is argument because this is reference. We have to use stdref syntax like this. Now let's run it. No, it doesn't work. In C++ 2A standard, double click this link. C++ 2A standard introduced template parameter. After clause, we can specify template parameter like this. Okay, so here it doesn't work. Then I create again std thread v. We can specify type name type like this. Then type R value reference arg, return arg times arg. This is lambda. Then we can provide std ref n like this. So C++ 2A standard will introduce template parameter specification at lambda expression. For more information about this, please refer to this document. I will copy this link and paste it here. Okay, this works in C++ 2A standard. Okay, now let's build. Here we have to change C++ 2A standard like this. Hit enter. A. Voila. It works successfully. If we try it with C++ 17 standard, it actually should not work. But in case of GNU, it already implemented. Okay, if we try it with Clang, we are trying it with Clang. No, it doesn't work because this is C++ 2A standard. 2A. It is not implemented. Let's try with Microsoft CL, EHSC, STD, C plus latest, O18, STD, REF, CPP, FE, AEXE. No, Microsoft does not work. So this works only for C++ 2A standard. As of today, May 25th, 2019, only GNU G++ compiler supports G++, STD, C++ 2A, O18, STD, REF, CPP. Let's try it once again using GNU 2A CLS. Yes, it works as expected. I will disable this part. Ctrl K, Ctrl C. I said this does not work. This does not work. I will copy it once again. I copied and pasted. I will change it to W. Then I will remove this part and I will copy and paste it here. Now if we change it to auto generic lambda, and this should be W, and this should be W, and W. This is called generic lambda. Now let's try it. We are using Clang C++ 17 standard. Okay, it works. W U7 W49, it works. Now with GNU compiler, it also works. So here, this parameter parameter. Since C++14, this is called generic lambda. Now let's think about this, how stdref is implemented. Right click, go to definition. So reference is a function taking reference with keyword no except specifier. It returns std reference wrapper. Okay, so we can implement like this here. Template type name, it returns reference wrapper type ref. Okay, type I say bar, then no except. It returns return ref reference wrapper type bar. It is implemented like this. If we pip into once again here, then we can right click, go to definition. If we see it carefully, it takes r-value reference. This is constructor, this is forwarding reference. Then it has pointer. So it is basically implemented like this. We create template type name type class reference wrapper here private. It has type M, I would say member. It is pointer. Basically, I would just say mptr like this. Then public, I will copy this here, type r-value reference bar. It is set like this using ref std forward type auto reference. It is l-value reference bar. I would say just l-value. Then this mptr, this is this ptr std address of l-value. Okay, this is syntactically equivalent to this. This actually means this mptr l-value. Okay, I will talk more about std address of in some future sessions. I will talk more about std address of in some future sessions. It returns the address of object or l-value. Okay, then it defines an operator like this. Operator type reference. It defines operator like this. Constant no except return this mptr. It is returning reference like this. It defines an operator. Then it can also have a cat like this, type cat It also has constant no except here, and I can copy this like this. Okay, reference wrapper is defined like this fashion. Then I will copy this part, this code, cut, copy, then I paste it here. Then I say example for custom ref. I modified like this. Then instead of std, we can now change it like this. We can simply remove std to test our function, our own ref. Okay, so we can modify our code like this if our code is working. Let's see here once again. Okay, now I will copy this function name and paste it here. I disable this part. Now let's double check. No std. std should be removed. Okay, now let's build CLS with GNU compiler. Let's see here. Template, type name, U type. Then copy, paste it. Then it is done type like this. Let's try once again. Sorry, copy, paste. Okay, so it works like this way. This is universal reference, so std reference wrapper is implemented this way, and using this ref is implemented like this way. So if you understand this concept, you can safely use stdref. I hope you understand this concept. In some future sessions, I will talk about address of standard library function. Please subscribe to my YouTube channel. Thank you for watching.